Hello, the purpose of this video is just to give you a little bit of feedback. I've just finished grading quiz 1. And so I wrote down 1, 2, 3, 4 things that you may be interested to review. So the first thing is that several of you made a mistake was, let's say something like, if I have f of x equals 2x to the second, let's say plus 3x plus 1. And the question is asking, find, say, f of 3x plus 2. So here I have f of 3x plus 2 equals 2 times 3x plus 2 to the second power plus 3 times 3x plus 2, and I have a plus 1 here. And many of you just thought that, okay, this is the same as saying this equals to, or let me rephrase that, f of 3x plus 2 equals 2 times 9x squared plus 4 plus dot, 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 dot. And that is incorrect. So 3x plus 2 quantity squared, in fact, is 3x plus 2 times 3x plus 2. So let me just clear all this in here and continue the correct way of doing this problem. So f of 3x plus 2 equals 2 times 3x plus 2 times 3x plus 2 plus 3 times 3x is 9x, and 3 times 2 is 6, and I have a plus 1 at the end. And that equals 2 times 3x times 3x is going to give me 9x to the second, and then I have plus 6x plus 6x plus a 4 plus 9x, and this I can say plus 7. And that equals 18x to the second plus this gives me 12x times 2 in here gives me 24x plus 8 plus 9x plus 7. So finally, this equals 18x squared. These two are like terms, so I have plus 33x plus 15. Okay, 18x squared plus 33x plus 15. So that's my first feedback. The second feedback from this quiz 1, is that you were asked to select all the functions, select functions, and you were given a bunch of graphs. Well, that's actually very easy. All you had to do is just use horizontal line test, use horizontal line test for every graph. So let's see. Does this represent, let's say, a function? Yeah, because every horizontal line you draw, it hits the graph only once. Is this a function? It is not, because a horizontal line hits it more than once. So keep in mind that you can always, when you're working with graphs, just keep the horizontal line test in mind. The third feedback that I want to give you is to get the domain and range from given graph. Domain and range. So let's say that you have a graph, something like an open circle here, goes down here, and then goes way up here. And this is, let's say, closed circle. Let's say this point right here is -2, positive, let's say, +2. Let's say this point right here is positive, let's say 3, -4. And let's say that this point right here is, let's say, 8, 7. Okay. So remember that in math, we always look from left to right. So the domain for this function, it starts from -2 in here, but -2 is not included. So I'm going to put a parenthesis because -2 itself is not included, and go from -2 not included, all the way to +8, all the way to +8. And +8 is included, so a bracket. How about range? The range is starting, look at the height, the least height that you have in graph, okay, is -4, and -4 is included. So -4 is included. And then go from -4 all the way to 7. And 7 is included because this circle is full right here. Okay. So once again, for the domain, you look from left to right. Start with your smaller number and go all the way to the highest number you can go. For the range, look from below, the smaller number, negative numbers usually, and go all the way as far as you can go. So if there's a particle, if there's a particle moving along this graph, this particle can go to -2. It can get really close to -2, but it cannot touch -2 because -2 is not part of the domain. There's a hole in there. Go all the way to the right, all the way to 8, and 8 is included. So I'm using bracket. And this particle have the lowest height this particle can have is -4. And the highest height that this particle can have is +7. Okay, and one last hint or feedback I do want to give you is that the domain of a rational function, So let's say that I have f of x equal, let's say, 2x plus 1, and then I have x squared minus 15. Well, here we know that this denominator cannot be 0 because 2x plus 1 divided by 0 is not defined. So how do I know at what values the denominator is going to be 0? Two ways you can do this. Well, just very similar. The first one, you can say, okay, x squared minus 15 equals 0, and factor that to x plus square root of 15 times x minus square root of 15, and that set that equal to 0. So you have x equals -√15 and x equals +√15. So you know that the domain is all real numbers, but x cannot equal to -√15, and x cannot equal to +√15. And if you don't like factoring, but I can think, why shouldn't you like factoring? You can say x squared minus 15 equals 0. Add 15 to both sides. Now I have x squared equals 15. And take square root of both sides. So I have x equals plus and minus square root of 15. So you know that x cannot equal plus and minus square root of 15, which is the same answer we had in here. Okay, That's it for now. Thank you.